Rahim. How are you, students? Today we will study physics, chapter number 10, thermodynamics, lecture number 46. Today topic is second law of thermodynamics. Before this we explain thermodynamics. First law of thermodynamics, thermal equilibrium. Zeroth law, temperature, heat and work, difference between heat and work, system surrounding, internal energy. First law of thermodynamics, and we also explain example of first law of thermodynamics. Then we explain isothermal process, adiabatic process, isobaric process. This one is isothermal. Adiabatic process, difference between isothermal and adiabatic, and few example. Today today topic is second law of thermodynamics. The second law of thermodynamics is a generalization of the law of conservation of energy. It tells us that heat and mechanical work are mutually interconvertible. You can convert mechanical energy into heat energy and heat energy into mechanical energy. The second law of thermodynamics tells us how energy can be converted into useful work. Heat energy can be converted into useful work. Compressing a system is useful work. The second law of thermodynamics can be stated in a number of forms, each emphasizing one or another aspect of the law, but can be proved to be equivalent. Now, the statement is here written that the entropy of an isolated system can never decrease over time and is constant if and only if all the processes are reversible. So the entropy, you cannot decrease the entropy of a system. If you decrease the temperature, if you increase the temperature, entropy of the system increases. Or if all the processes are perfectly reversible, then second law of thermodynamics, then the entropy will remain constant. In this case, we have two statements, Lord Kelvin statements and Celsius statement. There exists a useful thermodynamics variable called entropy, a natural process that starts in one equilibrium state and ends in another will go in the direction that causes the entropy of the system plus the environment to increase for an irreversible process. It means that if the processes are irreversible, it will cause an increase in the entropy of the system. Now, the second law of thermodynamics gives more information about thermodynamic process. Second law may be defined as heat cannot flow itself from cooler body to a hotter body. This is Celsius statement. It is impossible to cause heat to flow from a cool body to hot body without the expenditure of energy. Other way, heat can be made to flow. Heat can be made to flow from hot body to cool body, cool body to hot body by the expenditure of energy. For example, if you give electrical energy to refrigerator, it make heat flow from cool body to hot body by the expenditure of energy. I will explain it in the coming example. Let's study the statement. Second law is also used to determine the theoretical limits of the performance of mostly used engineering systems like engines and heat pump. What is the second law of thermodynamics? Entropy is in an isolated system that is not in equilibrium will tends to increase over time until it reaches a maximum equilibrium level. So entropy of the system will always increase. It will increase until and unless the both the system comes into in thermal equilibrium. If you keep the door open, this is the interaction. If you open this place, heat will flow from hot body to cool body to, between two adjoining rooms of different temperature. The cooler room will become warmer and the warmer room will become cooler until they both reach the same temperature. Second law of thermodynamics, Kelvin-Planck's statement. It is impossible to construct an engine or a machine which operate in a cyclic process whose sole effect is to convert heat into equivalent amount of work. It is HTR, high temperature reservoir. High temperature reservoir. It provides heat to the system. Let's say Q1 amount of heat is taken from this. A part of this is used to do work and the rest of the heat is rejected. So, according to this statement, it is impossible to construct an engine which take heat from the HTR, high temperature reservoir, and convert it completely into work without rejecting heat. So it is impossible. The second law of thermodynamics, the Kelvin statement. The Kelvin statement, Lord Kelvin statement is also, you can state it like this. It is impossible to construct a heat engine operating continuously in a cyclic process which take heat from a high temperature reservoir at higher temperature and performs an equal amount of work without rejecting heat. So, according to the Lord Kelvin statement, it is impossible to construct an engine where there is no loss of energy. Where there is no loss of energy. For example, if here is a system HDR and Q1 amount of heat is taken from it, a part of this is used to do work and the rest of the energy is rejected. So work done will be equal to Q1 minus Q2. Q2 is the heat rejected, Q1 is the amount of heat taken from HDR. This is called sink, to which heat is rejected. Entropy is a measure of the disorderness in a system. All systems gain entropy over time. The second law of thermodynamics says that the total entropy of both a system and its surrounding will never decrease. It will always increase. If you decrease the temperature or increase the temperature. Again, Lord Kelvin statement. It is impossible for a system to undergo a cyclic process whose sole effect are the flow of heat into the system from a heat reservoir and the performance of an equal amount of work by the system by the surrounding. Lord Kelvin statement. If heat is taken from this system, it cannot be converted completely into work. There will be losses. We cannot construct an engine in which work done is equal to the heat gain. We cannot construct. It never happen. If it happen, all the processes will be reversible perfectly. It is impossible for a system to undergo a cyclic process whose sole effect are the flow of heat into the system from a cooled reservoir and the flow of an equal amount of heat out of the system into a hot reservoir. Celsius statement. Heat can be made to flow from cool body to hot body by the expenditure of energy. Kelvin-Planck's statements of second law of thermodynamics. It is in more detail. It is impossible for any device or a device as heat engine that operate on a cycle to receive heat from a single reservoir and produce a network. If You take heat from a HTR, high temperature reservoir. Given amount of heat is taken. It cannot be converted into work completely without rejecting heat. Q2. Without rejecting heat. No process is possible whose removes heat from a single thermal reservoir at a uniform temperature and performs equal amount of work. Heat cannot be converted completely into work. Second law is the restriction of the energy transfer. First law, energy is conserved, heat is a form of energy transfer. Kelvin statement, there is no process whose only effect is to accept heat from a single heat reservoir and transform it entirely into work. No heat engine operates continuously in a cyclic process. In short words, and Celsius, heat can be made to flow from cool body to hot body without the expenditure by the expenditure of energy. Lord Kelvin statement in another way. It is impossible to extract an amount of heat QH from a hot temperature reservoir and use it all to do work. It is not possible. Some amount of heat QC must be exhausted to a cool reservoir. It is impossible that if you take heat from HTR and convert it completely into work, it is impossible. Some heat will be rejected. Some heat will be rejected. Celsius statement. Heat cannot spontaneously flow from cool region to a hot region without external work being performed on the system. Example is refrigerator. Heat cannot flow from inside of the refrigerator to outside without the expenditure of energy. If you provide electricity in means provide energy to the refrigerator, it take heat from cool reservoir and transfer it to the surrounding room in which refrigerator is kept. You keep the refrigerator, that room is the sink or low temperature reservoir, sink or LTR or low temperature reservoir. Low temperature sink or low temperature reservoir. Low temperature reservoir. This is inside of refrigerator. Heat is taken and here we provide electricity and transport to the room. Now Celsius statement. This is low temperature reservoir. Low temperature reservoir. So from this heat is taken by providing energy to the system. By providing energy to the this is low temperature reservoir. If you provide heat to the system, it will take heat from the low temperature reservoir and transfer it to the hot temperature reservoir. QH is the amount, Q1 is the amount of heat taken from the LTR. Here we provide energy and with the provide electricity, and Q2 amount of heat is rejected. So work is equal to Q1 minus Q2. So it is impossible for any system to operate in such a way that the sole result would be an energy transfer by heat from a cooler body to a harder body. Example is refrigerator. Now we studied that we studied two statements for second law of thermodynamics. Lord Kelvin statement. Lord Kelvin statement. Heat can be made to flow from cool body. It is impossible to construct an engine which continuously operates in a cyclic process. In a cyclic process, it is impossible to construct an engine which continuously operates in a cyclic process. According to Celsius statement, it is impossible. It is impossible. It is impossible. It is impossible to make heat to flow from cool body to hot body, from cool body to hot body, without the expenditure of energy, without the expenditure of energy. It means that heat can be made to flow from cool body to hot body if you provide energy to the system. This is the cyclic diagram for Carnot engine. But before going into detail of Carnot engine, first we will explain heat engine. Heat engine. A heat engine is a device that converts heat energy into mechanical energy. That converts heat energy into mechanical energy. Mechanical energy. That convert heat energy into mechanical energy. Heat energy. Steam engine, petrol engine, and diesel engine are all the example of heat engine. Steam engine, petrol engine, and diesel engine are all the example of heat engines. A heat engine consists of the two parts. A heat engine consists of two parts. HTR, high temperature reservoir. Heat source or heat reservoir. HTR, high temperature reservoir. Heat source. It is a very large reservoir or source of heat energy. Source of heat energy. Source of heat energy. Provide heat to the system. Provide heat to the system. And is at higher temperature T1. Its temperature remains practically unchanged during any transfer of heat into or out of it. It is also called high temperature reservoir. The second portion is consists of low temperature reservoir. LTR, low temperature reservoir. It is a very large body or reservoir at low temperature. Its temperature is T1 and the low temperature reservoir temperature is T2. T1 is greater than T2. Its temperature remains unchanged, practically constant during any transfer of heat into or out of it. It is also called low temperature reservoir. Now we will calculate efficiency of the heat engine. It is HTR, high temperature reservoir at temperature T2, and it is LTR, low temperature reservoir at temperature T1. A part of this heat, Q1 amount of heat is taken from this at this temperature. A part of this heat energy is used to do work, and some of the heat is which is Q2 is rejected to the surrounding, to LTR. So a part of this energy is used for work done, useful work done, and the rest of the heat energy is rejected. So work is equal to Q1 minus Q2. Our work is equal to T1 minus T2. Both are correct. It is in term of temperature, it is in term of heat energy. So if according to Kelvin statement, it is impossible that work will be equal to Q1, that whole of the amount is used to do work against is used, whole of the heat is used for useful work done. Nothing is rejected. There is no heat lost. It is impossible according to Lord Kelvin statement. Now we know that work is equal to Q1 minus Q2. So efficiency of the system or engine is equal to work done by the engine divided by heat absorbed from HTR. This is called eta, represents efficiency. If you write percentage, you will multiply with 100. Q1 multiplied by 100%. So percentage efficiency is equal to Q1 minus Q2 divided by Q1 multiplied by 100%. So percentage efficiency is equal to Q1 divided by Q1 minus Q2 divided by Q1 multiplied by 100%. Percentage efficiency is equal to 1 minus Q2 divided by Q1 multiplied by 100%. In terms of temperature, it can be written as term of temperature. Percentage efficiency is equal to 1 minus T2 divided by T1 multiplied by 100%. Now, today we studied heat engine and second law of thermodynamics. In second law, the first statement of second law of thermodynamics is it is impossible to construct an engine. It is impossible to construct an engine which continuously operate in a cycle. To construct an engine which continuously operate in a cyclic process. Continuously operating in a cyclic process. This is Lord Kelvin statement, and the Celsius statement is heat can be made to flow from cool body to hot body. High temperature reservoir. Heat can be made from cool body to hot body by providing energy to the system at the cost of the internal energy of the system, or by providing the energy to the system. So here both the statement are accurate at their own position. Lord Kelvin stated that heat cannot be made to flow from heat can flow only. No heat engine continuously operate in a cyclic process. Means there will be loss of energy. Heat cannot be converted completely into work. Some of the heat is rejected to the surrounding. And Lord Celsius statement said that heat can be made to flow from cool body to hot body by the expenditure of energy. And the third, and then we explain heat engine. Heat engine is a device. Heat engine is a device which converts mechanical energy into heat energy. Heat energy into mechanical energy. Heat energy into mechanical energy. Mechanical energy. Heat energy into mechanical energy. It consists of two parts. HTR, high temperature reservoir. High temperature reservoir. High temperature reservoir. High temperature reservoir. And LTR, low temperature reservoir, also called sink. So It is a very large body. LTR is very large body. Small amount of heat which is rejected by the heat engine cannot affect its temperature. And HTR is a high temperature reservoir, and its temperature cannot be affected by taking Q1 amount of heat from HTR. So, and then we calculate the efficiency, which is equal to 1 minus Q2 divided by Q1, and in term of temperature, efficiency is equal to 1 minus T2 divided by T1. So next coming topic is Carnot engine, and we will do it in the next coming lecture. Thank you, students. Allah Hafiz.